I welcome you all in this lesson 3 where we are going to discuss about debugging, testing and backward compatibility. We all have been learning about Android for a long time now. We know how exactly we can create activities, we know about the intents. So let's just learn about how we can actually test our application also, how exactly we can find our errors, how exactly we can debug them. So first we are going to discuss about debugging. In this particular session, we are going to discuss about what are bugs, what are different tools to debug those bugs. Android provides the logcat, Android provides debuggers, how exactly we can go through those breakpoints. We're going to see all of that in this particular session. So what are bugs? Well, bugs are something which gives you unexpected result. It can be an error. It can be something when your application freezes up, or it is something when your application crashes. So all those are considered to be bugs. How exactly those bugs can be caused? It can be human errors. It can be a code which a human which a developer never thought of encountering it. For example, let's say you put a code a divided by b. Now this code will work for all the numbers, all the numerical values until and unless you do not put b equals to 0. When denominator is 0, it will give no result. So that was something a bug which was a human error. Second, it can be a software fault. Let's say you have created an application and there are basic requirements for that application. Your platform version should be particularly above 21 because of the feature your application is using, and you are trying to run that application in a platform which is lower than that. Your application still won't work in that because there is a software, or there may be glitches inside your software itself. Then it can be a hardware fault too. In your hardware fault, when we talk about hardware, let's say your application uses navigation system and there is no sensors for that. There is no navigation system inside your device itself. So again, that's a hardware bug. Now, so what is debugging? Debugging is something where you fix those bugs. First, you find the bugs and you fix the errors, and so that you do not get your undesired result. Now, testing is one of the ways to find the bugs at the early stages of your development itself. There will be two types of testing which we will be discussing in our later sections. That will be UI testing and your unit testing. Now, Android Studio provides you different debugging tools which are perfectly capable of identifying the problem, find the problem inside the source code, and then you can fix it. First debugging tool which is very popular and which we have been using up until now is your logcat. Now let's just take a closer look at that at this logcat. How exactly you can create or put a logcat statement. When you for putting a logcat statement, you need to use a class log, and inside that, let's say you want to put a debug type of log, you will use log.d, then there will be a tag name and your message, whatever the message you want to put inside your logcat. Well, this is how your logcat looks like. Logcat will be inside your Android monitor, and inside Android monitor there will be a logcat tool, and your logcat logs all the activities which have been done inside your emulator or the connected device. And if you want to put your own log, you have to put that log statement inside your activity, in whichever activity or whichsoever activity is being shown to your user, and wherever you put that log will be shown inside your logcat then. Now, there are different kinds of log, and if you want to filter out your own log, let's say you have kept inside your application debug log only, then you can always drop down then you can always use that drop down menu to filter out your own kind of log. Now, there are logs like we discussed, verbose. Verbose will show you all kinds of log together. Debug will show you your debug logs. It can be all any debugging logs which have been generated by your which have been generated inside your emulator or your physical device, or if you have kept any debug log inside your own application too. Info log will give you the status info, generally used to provide the info inside your activity itself. You will be generally using it, pretty much using it in debugging your applications. Let's say your application is getting crashed and you want to know at which point your application is getting crashed. So you will be putting these logs at certain points or milestones, so that you get to know, okay, at this part of code my application is getting crashed. Warning log gives you the logs about unwanted behavior or non-fatal issues. Errors will give you the logs about all the errors which you get in your application. Whenever your application gets crashed, it will give you the reason it is getting crashed, exceptions and all. Those logs are errors, error log. Now let's just discuss about a better tool to debug your application. That would be Android Studio Debugger. Now, with the help of debugger, you get more options to debug your application as compared to Logcat. Well, what you can do with the debug as well, you can set the breakpoints in debugger. That's a pretty cool feature here, that you can always, let's say you think that inside this particular method, there might be an error or there might be a debug. Now you don't know at which line and you don't know at which point that error might is being generated. So you will set the breakpoint at the starting of that method, and you can again set another breakpoint at the ending of that method. Now while you execute your application will stop at that breakpoint before really getting inside that method. So that's what the debugger mode is. Now to run your application in debugger mode, you do not run your application in a normal mode. You run your application in debugger mode. We will see how exactly we do that. Now at the very top, we always run our application by using that play button, but this time to run your application in debugger mode, we have to use the debugger button. And when you click on that debugger button, your application will, your Android Studio, at the bottom of your Android Studio, automatically a debugger pane will be opened up. Now, to set the breakpoint inside your activity or application, there will be a left gutter, and inside that whichsoever line you want to set the breakpoint, you just click on that particular line in the left gutter and a breakpoint will be set. Now, every time you run your application, before actually running your complete application, your application will stop at that breakpoint, and it will require the user interaction. It will require a developer interaction to resume that particular, to resume the application to run from that particular breakpoint. Now you can always edit the breakpoint by clicking on the breakpoint in the debugger pane also, or you can set the conditional breakpoints also by right-clicking on any breakpoint and set any condition you want. Your app will run until it doesn't find a breakpoint. As soon as it finds a breakpoint, it will stop and it will require you to run the resume the application. As soon as you resume, and if it doesn't find any error, it will stop until it doesn't find another breakpoint. If there is another breakpoint, your app will stop there too. Let's say there are no further breakpoint, your app will execute completely if there are no errors. Now, in your debugger mode, your debugger mode has been divided in 3 panes. First pane is known as frame pane. Inside your frame pane, your current thread is executed. Whosoever thread is executing at that point of time, that thread classes and objects will be shown inside your frame pane. Inside your variable pane, all the variables which are running inside that particular thread will be shown inside your variable pane. You can always edit those variables by right-clicking into it and change the variable values. Now there are some commands by which you can always by which you can always step into or step over to or force step into or step out from any particular code also. From any particular code. Let's say you want to step over a particular code. Let's say you don't want to get into the details of executing that particular method. You just click on step over. If you do want to execute the next line by line, you will use step into. And if you want to step into a code which you were not supposed to, like a standard Java class, standard JDK Java class, that you can do by using force step into. And if you are using step out, then you can always step out from the method whichever you are executing right now and get to the next executing point. And run to cursor will make sure that wherever you are, wherever your cursor is right now, it will start executing from that particular line. So you can always find these buttons over the debugger pane too. This is how your icons will look like. Your application, you can always resume and pause your application while your application is running in your debug mode. Or you can always mute all your breakpoints by using mute all icon too. Now let's just see a small demo on debugging. We are going to create a new application. Go to new project and name this debug app. In this particular application, I'm going to debug it with the help of Logcat, plus I'm also going to use our Android Studio debugger too. So as you can see, this is how my application looks like as of right now. So I will create a completely, I will create it from very scratch. I will put a text view and call it debug app and increase the font size to 30 sp. Call it debug app. Good. Next, I'm going to create a edit text. What I'm creating here is a small Kelsey, which doesn't do much but just addition. But you can always create a complex Kelsey too. Our goal here is to see the debugging working here. Our goal here is to see the Logcat and debugger working. I'm going to put enter first number. Enter second number. Put it in the hint, match parent, and put edit to. Now I'm going to create a button. Call it add. And inside this button, there will be on click. On click, we call it do add. And then to create the same method in my Java class, press Alt Enter and then just click on this, and it will create the same method here, the handle method. Now I do know that I will be needing the access of those two edit text, so I will put edit text E1, comma E2. And E1 equals to edit text find view by id r dot id dot edit 1. Same goes with edit 2. Edit text find view by id r dot id dot edit 2. Okay, next is if I want to show the result also, once you add these two things and want to show the result, I will put a text view just below my edit text, and I will change the attribute of this, maybe 36, and I call it your result in starting result. And then let's say my result is the ID to this. So this is where your result will be shown. So I will be needing the text view too, tv1. And how do I get the access of tv1? tv1 equals to text view find view by id r dot id dot my result. Next is I need to add those two numbers which my user is providing to my edit text 1 and edit text 2. So first of all, there should be integers, so I will put int a1 and from where exactly I'm getting the data? From e1 dot get text dot to string. It will always give you string, but you do not want string, so you need to parse this. Integer dot parse int and same goes with the second one, int a2 integer dot parse int s2 or sorry e2 dot get text dot to string. Now all I need is a variable, let's say int result equals to a1 plus a2. And put the result back in my set text result, and there you go. Will be working perfectly fine. Now let's just see the output. So this is how my application looks like. There is a first number, there is a second number. Let me put 23 as my first number, 23, and 34 as my second number, and you get the result. So you see now my application is getting crashed. Now as you can see, my application is getting crashed. So let's just see where exactly is the error. So for that you always need to go to Android monitor, and inside Android monitor there will be a logcat, and logcat logs all the things which you put inside your logcat logs all the things which is happening inside your emulator. Now as you can see, this is the error which is causing your application close, which is causing your application crash. Now if you click on this, as you can see here, at this particular line at this particular line the error is. Now let's just see what exactly the error is. It caused by resource not found exception, string resource ID. Now let's just check what's that. Dot ID dot my result. Now as you can see, there is an error. So how exactly you can fix this error? Now you see there is an error somewhere inside this line, as you can see with the help of logcat. Now to figure it out, if you can't figure it out what exactly is the error, you can always put log statements here. Let's say log I main activity and make it executed 1, and in this way you can copy this statement and start putting from here. Now let's just see where exactly that error occurred. Now this time around, if I check this out and try to add again my application will crash. But let's just check out the logcat this time. Now as you can see, executed 1, executed 2, executed 3, executed 4. So till 4 it was fine, but after this it wasn't fine. So at this point of line the error lies. So logcat can be very helpful in those in the programming where you don't have much complex code, but you do want to find out at which part at which line of code there was an error. So here you can see I just found out that at this point of line I was not able there was an error. So what is the error here? I didn't converted it to string part or string variable. So now it is in string variable. Now the application will work fine. So in this way you can use logcat. Now let's just run and see this. I just put 23, 56 and add. There you go. Now this was how to use logcat. Now if I am to use the Android debugger here, for an application to use Android debugger, you have to first stop your application running in a normal running mode, but run your application in a debug mode. Just click on this icon and select the emulator, and your application will run just like any normal running mode, but this time there will be a debugger pane at your console also. So you can see your application is still running normally. Now let's just do the same mistake which we did initially while we created the logcat. Instead of putting it string, I just put it integer. Now how will I rectify this error with the help of debugger mode? If I try to run this application with debugger, you will see if I put something add, my application crashes, right? So how will I rectify this error with debugger? Now I can put, with the help of debugger, I can put breakpoints. Now whenever I put breakpoints, my execution of program will stop at that particular point. So now let me run this again, not in a normal running mode, but in a debug mode. So when I do that, you can see if I put any number now and press on add, your app freezes because it sees that there is a breakpoint. Now to execute that breakpoint, you have to click on this resume first. Now click on this resume. Now automatically your app freezes to your next breakpoint. Now we know that there is no error at this point because we have already checked it with the logcat. So I will again click on my resume and it will freezes at my next breakpoint. And that next breakpoint, I do know that there was an error. Now when it executed that breakpoint, that is the text 1, your app crashes. So now I know that inside this method there is a problem and we need to fix, we need to go through the code again inside this method only. So I will again fix the error and put it as a string type. Now let's just go with this whole code again as a breakpoint, and you will see that there will be no interruption this time because the code has been fixed, and even though it will stop at the breakpoint, but after that it will execute like just any other program. And resume your program, and there you go. You can see the output. So there was a small demo for debugging. You can check out the complete demo in your practical books. Hi everyone, I'm Lalit Singh. Welcome back. Now we have seen how we can debug our app. Now let's just learn about testing too. In this particular session, we are going to know what exactly is testing, why exactly it's worth our time, and what exactly is unit testing. First thing first, why exactly testing is needed? Now let's say you are developing your application and you have released your application into the market. Now people find that there is a error, or there is your application is not performing or giving the desired result. Now your application comes back to you, and now you have to find all the bugs at that point of time at the production level. So the cost will be higher at that point of time. So it is good that if you find the bugs at the early stages of development itself. So that's why testing is needed. So find and bugs at early stages will cost you less and will take less effort. With the increase in time with the development in your application, it will take much more time to find your bugs, and it will be much expensive too. Types of testing. When we talk about types of testing, there are levels of testing also, known as component testing, integration testing, protocol, and system testing. In component, we test component-wise integration. We put it as whole protocol. Protocol testing is related to the protocol we define, and system is testing the whole system itself. When we talk about types of testing, it can be a testing type. You can test it with the installation. You can test whether it is giving you the compatibility, or if it is acceptable to the user, if the performance of that particular application is adequate or not, or the scalability. In the same way, there can be a user testing also. When we talk about user testing, it can be automated UI testing or instrumented UI testing. And we will talk about UI testing more in our further sessions. Let's just talk about test-driven development. Now, this is the process you will be following every time you want to test any application. First, you will define a test case according to your requirement. For example, let's say you are testing a Kelsey. At that point of time, you require to make your test cases according to the Kelsey. Now, let's say you are using a database application, then your test case will change according to your database requirement. Maybe you want to check out whether you are getting all the records whether you are getting all the records or not. Now, once you make all the test cases, then you have to write the code regarding to that conditions. And once you put the code, then you have to test that test cases. You will get two results. One will be your actual result. Another one will be your expected result. Now, if there is a difference between them, that means your test has failed. Then you have to repeat all those steps again. When we talk about the testing your project, where exactly you can find your test projects. Now, in your Android application, when we talk about your Android application, there are mainly three projects. One is known as main. Inside main, you will put all your development classes. Then we have test package, in which you will be putting your unit test classes. Third is known as Android test, in which you will be putting all your instrumented test classes, or we can say UI testing classes. Let's just talk about local unit test classes, because that's what we are going to cover in this session, unit testing. Unit testing is testing a smallest unit or smallest component of a project or a program. You will be testing a component individually and getting the result back. In this way, you will be testing many single unit, or in this way you will be testing many components, many single components, and getting the result back. Each component unit will get the inputs, and there will be a result, and there will be a graceful failure. Now, don't think that at the very first try you will pass the test. There will be errors, there will be failures. Now, every time you get into the failure, you have to change the inputs. You have to keep on trying to change the inputs and get the expected result. When we talk about JUnit testing or local testing, they are being performed inside your JVM only. So you do not need any emulator while you are doing the JUnit testing. So whenever you will be performing the JUnit testing, all you have to do is, all you need is your Android IDE, and when you will be running the test, the result will be inside your console itself. You will be able to see in the console itself. All the test classes which you will be using in your local JUnit testing will be taken from JUnit class. Local JUnit testing classes are gathered inside the package source, and inside that there will be a test package, and inside that there will be Java, where you will be putting all your JUnit test classes. Only JUnit class is needed to import. Only JUnit class is needed to import. No Android framework class is needed while you are doing your JUnit testing or local unit testing. Android framework class will be needed when you will be doing your Android UI testing. While we are performing our JUnit testing, you need to import all your JUnit classes like JUnit.test, JUnit.before, JUnit.runWith, JUnit.JUnit, or JUnit.runner.JUnits. So all these classes will be used inside your local testing. Now, to perform the unit testing, the very first annotation which you need to provide is @runwith, in which you will be providing the class which you will be using for this local unit testing, and that would be JUnit4.class. and you give the class name, maybe public class, my own class, and inside that you will put the methods. Now, to make any method behave as a testing method, you have to put an annotation @test. If you do not put @test annotation, now at that point of time, that method will behave just like any other Java method. To make your method behave as a testing method, you have to put annotation @test. Once you put the @test annotation, now when you run your testing class, your method will start testing whatever the code you have given inside that particular method. @annotation has been inherited from your JUnit 4 test class only. And it is not necessary to put the test prefix before your testing methods anymore. You can just put any method name, and if you want to make that method name and if you want to make that method as testing method, all you have to do is put the annotation @test. Now, if you want, before you start your testing method, you want to initialize certain variables or objects, you will be using a method called setup. Now, this setup will only run before the testing method if you put an annotation known as @before. Once you put the @before, whatever the data you have given inside that setup method, it will run before your testing method. Teardown is the method which will always execute once your testing is done. Now, there might be a chance that while you were testing your application, you must have used many resources. After you are done with your testing, you do want to release all those resources. So how exactly you make any method behave as teardown method? For that, you need to include an annotation known as @after. And once you do that, the method will be executed right after your testing is done, and you can release all the resources inside that teardown method. So how exactly testing is done inside your Android Studio? To perform testing, either you can right click on your testing class and then run your class as a testing class, or you can right click on your testing package and then run your package as a test package. In both the cases, it will start running your application in testing mode. If all the testing cases and all the testing methods which you have defined inside your testing activity or application are passed, then only it will show you a green progress bar by telling you that the test has passed. If there is even a single method or testing case which has been failed, it will show you a red progress bar telling you that this is where your test got failed. When we start testing your floating point, we have to take extra care with the floating point. The reason behind that is because floating point has a precision value also. For example, let's say I have two values to add. Now, once I add these two values, I will get a result back. Now, if that result is, let's say, for example, if that result is 50.0.000.4, but I'm only getting 50, then there will be a error and your test will not pass. So that's when you want to provide some relaxation or some precision value to your floating point numbers. So you can do that with the help of assert equals. Assertion methods are used for checking out your test cases. You will be using all the assert methods to check out your test cases. Here you can solve this error by providing a particular range of value till which you want the relaxation. For example, that same value 50.00005. Now, if you do not want to care about the decimal point, there will be a third argument where you will be providing till which point you do not care about the precision value. And once you provide that, your test will get. Now let's just see a small demo on testing my application with JUnit. Now I will use my previous example only, where I showed you the debugging of app with the help of Logcat and debugger, where I created a small Kelsey, as you can see, which was showing me nothing but the add structure, nothing but add functionality. Now, what we can do is To do the JUnit testing, I need to go to the JUnit testing package, and this is what this is the JUnit testing package. As you can see, example unit tests. Now, when we go inside example unit test, you can already see that there is already a addition is correct method which is being used here, and which uses a assert equals method, which checks whether the first object, that is 4, and then 2 plus 2 is actually equals to whether these two objects are equal or not. If we try to run this test right now, it will show me true, because they both are when we calculate, they both are actually true. It also gives me 4, and this second object is also 4. Let's just try to run this. To run your application in testing mode, right click on your file and run example unit test. As you can see that we got a green progress bar. Now let's just change the parameters here. Now you can see that one argument will give you 3, another argument is giving you 4. Now it shouldn't give me a pass test case. Now let's just try. As you can see, the test failed because the expected value was 4 and the actual value which we got is 3. So in the same case, or in the same way, I can create one more test case, that is public void multiply. And we can check assert. There are so many assert methods which we can which you can use. As of right now, I will use assert equals, and I will put 12 3 into 4. Now, until unless I do not put the annotation @test, this particular method will not behave like a testing method. To make it behave like a testing method, you need to put the test. Now let's see what it gives me. As of right now, it will show me an error because my first test case fails. So if I run this again, as you can see, and the error is inside here. Error is inside your addition method. It is as you can see, it is specified here. Let's just fix this one. Now, as you can see, now there is no there shouldn't be any error, so you should get the green progress bar. So until unless all the test cases are passed, it won't show you any green progress bar, or it won't pass your test. Let's just change this a bit. Now it should again show you a red progress bar. See, so that's how your JUnit testing works. You need to create different testing. You need to create different test cases, and while you want to make them behave as test cases, you need to put the annotation @test, and inside that you can always use any assert statements to check it out.
The MCQ of this lecture are: first thing, it is not a method for debug an error using text view, using log, using test, toast, and manually remove the error. So what is the answer? So the answer of this MCQ is using text view. We didn't not remove the any error from the error. Using log we check the error, using toast we check the error, and manually we search the error in any error. So the answer is A, using text view. Second is which is not an error. There are many errors, crashes, exceptions, incorrect or unexpected results, and fourth is emulator. So crashes also an error, exceptions also an error, incorrect or unexpected result is also a error. But emulator is the Android virtual emulator which run your apps on the mobile screen as a mobile screen virtually. So emulator is not an error, it is a tool. So the answer of this question is D, emulator. Next is example of log. The right syntax to create a log are a log.d tag hello world. Second is log.d tag hello world. Log.d tag hello world. And next is log.d hello world. So first is the answer of a right syntax of log. Log d tag comma and in inverted commas you insert the text that you want to insert into log using the tag. So answer is A. Which is not visible logging panel? Which is not visible logging panel? There is Barbos, debug, info, and the last is server. So Barbos, debug, info are the part of a logging label, but server is not a part of logging label. So the answer of this MCQ is server. Next is, what is the Barbos? The definition of Barbos: statements and compressive system, variable value debugging nodes. Next is status info such as database connection, and last is unexpected behavior and non-fatal issue. What is the Barbos? Barbos is the statements and compressive system. Next MCQ is, what is the debug? Debug means statement and compressive system, variables value debugging nodes, status info such as database connection, and last is unexpected behavior and non-fatal issue. So there is the B option, variable value and debugging nodes. Next is commands for step over. So F8, F7, F6 and F4. So the answer of this MCQ is F8. Using the F8 you run the step over. And now next is command for step in. Command for step in F8, F7, F6, F4. So the answer is F7. Next is, which is not type of testing in Android app? First is performance criteria to testing any Android app: performance, scalability, usability, and last is limitations. So performance is the criteria to testing any Android app. Scalability also a criteria to testing any Android app, and the usability is also a criteria of a testing app, a Android app. So last is limitations is not a criteria for checking the any Android app. So answer is limitations. And last MCQ is, which is not a label of testing? First is components, integrations, protocol, and last is tree. So components, integration and protocol is the levels of testing, but tree is a not of level of testing. So the MCQ of this lecture is over. Thank you very much to listening me.